Awesome. Hi, I'm Ezekiel Descoli, and this is my code review for the final project. So the first thing that we're going to do is start off with a hierarchical overview of how we decided to organize the assets in our game. And so you can see here that everything lives under the major assets folder. And a few of them are imported directly into the assets folders, things like Polygon Sci-Fi City, some of the extra assets that we had, like some of the models that we imported, these are from Blender. Like this matrix shader assets, when we were all collating them together, they ended up top level here. The animations that we built for the game also live in this animations folder. You can see everything is pretty accurately named to define and segment off where we put and how certain code. So animations live here, and the real heart of it all lives inside of the scripts folder, which houses things based on what type of entity uses those scripts. So yeah, it's pretty basic setup, pretty standard. We're just going to take a look first at the scene 1 here. You can see if we can fly around the level here. This is the spawn point. To go over the feature that I implemented, we can go to this little alleyway. And so the point of this level is that you spawn over here, you go to this nightclub, and you see there's enemies around, and you're navigating the area, and you have to find a way inside. So the part that I did was this alleyway. I created security camera models in Blender, and then realized that this asset pack, Polygon Lo-Fi City, has actual security cameras in it, so I went back to using those. But these cones here were all made in Blender, and then brought in. And the premise is basically you got to sneak by this like very secured alley, and you have to sneakily manage your way through when these are rotating back and forth. And so originally they were animated with code, and as we got to the final project, they got animated with animation controllers. But these all have collisions on them that will play a sound and notify the enemies on collision, so that it'll lose player health or notify the guards, depending on how we implemented it per level. And so I also implemented this door here, which if you go to the door, and there's a few of these inside of the level as well, but you can see that they have a box glider on them, and that those are triggers for when you get near enough to them, they will allow you to go right inside. And so we can go through, and you can see there's 2 here as well, and those all trigger, and you got to go through and find the shipments. And so yeah, so that's the feature that I implemented for this level. And let's see, one major game mechanic. So here's how I actually implemented that game mechanic. So for the problem, we have these inputs and outputs, and the inputs that we have are all these different weapons. It could be an arbitrary amount. We just want to select one of them. And we have input controls, and for us we chose the joystick. And the joystick can be any number of directions based on a vector2 input that it's given. And so what we want to output is we want to have, the way I decided to implement was a radial menu. And we want to take the direction chosen by the player and map that to one of the panels. And so you can see here that like this direction going right would select this panel. And so how I went and do this, and I thought this was so clever and ingenious, and I realized that now this is actually like when I looked it up afterwards, the standard way to do this sort of thing. And it kind of deflated like that moment I had of realization, but it still felt good to know that I came up with a relatively well understood solution. And so the method is actually taking in the joystick's input, which will look something like this as a vector2, and then taking the directions based on the panels. Like if we're going to map this joystick to this panel, we can picture it from above, where each panel has a vector associated with it, each panel representing one weapon. And we can map this above, like overhead. Like imagine this is the joystick and this is the vector input. You can see that it's mainly pointing to the right, but it's pointing a little bit up too. So how do we cleanly divide this radial menu into this option here? And so what we can do is we can take each vector one by one. So take the first vector here, and we want to compare this in some way to the input vector. And the way I thought of doing this was taking the dot product, because that's a way to take 2 vectors and get a scalar measurement afterwards. And so we take the dot product like this one, and we're going to do it for each of the vectors as we go through, and keep track of the maximum. And the maximum dot product will be the closest vector to our input vector. So if we take the dot product of this one, of all these ones, and we compare it to the first one, the current max is set to the first here. When we do the second, this is now a bigger dot product, so we keep this one. And this is a smaller dot product, so we still keep this one. And this is a smaller dot product, so we still keep this one. So really the closest vector is this one, and we highlight that panel and select that weapon. So that's a high-level overview of how it works. And in code, you can see that it looks pretty identical. And we just see here, and this is an old build of the code that has all my assets before they got like collated into the final project. So you can see here, because a little bit of the code changed, and it's easier to see in the initial programming here. So you can see we just go through all the vectors that are here, and ideally this would come from like a weapons manager, and we just find the maximum dot product. and then associate the weapon to that. And we call select the weapon by index from the weapons manager and highlight this one by the UI. Now, when we actually go to the final program, it looks a little bit different, but it's pretty much the same. Instead of having like a weapons manager and a weapon switch and a weapon UI and kind of having those all segmented responsibilities, we collapse them all into one radial menu, which keeps track of the inventory and all the panels all in one. But the code, you can see, is still there. Like, it's still the same premise, and the highlighting and whatnot just all takes place in the same file. So that's how that feature was implemented. All right, and finally, we're going to go through all the code that I had touched. And again, I'm going to go through the original one because not all of the final programs that I had written actually made it into the program because we felt it a little bloated. And so originally, like I showed just now, the weapon switch and the weapon manager. And this, I was just using a basic interface where like you could do this if you wanted to. I was just using the dummy one. And so I went over weapon switch and weapon UI. This is somewhat trivial. Like, we went over how to highlight objects in Unity in class. And so this does kind of the same thing. And where we go through and we show or hide the panel based on whether or not you're, past a threshold in the weapon switch. So if you're past this threshold, then you'll go and you'll show the weapons UI on the right controller, and then it'll get highlighted to the right one. Other programs that I had written that didn't make it into the final one were this spin oscillate, which basically just, the problem was that, like, once we all broke off and did our own like problems and then collated them together, we all had kind of ran into similar problems, and so we'd all programmed like similar solutions, and so we didn't need to have superfluous code, so we just distilled it down to like the best bits of each little program. So this one is a spin oscillate, which would just take an object and either spin it and oscillate it up and down based on some amplitudes and periods, some public functions. And you can see that we can do the open door, which would trigger an animation if they ran into the collision. Lose health on collision, so when the security camera ran in, it would make the player take damage. Later that turned into alerting the guards. And then another feature that I implemented that we didn't make it in, but it would have been kind of cool to build a level off of, was a force cannon, where you could fire, like you could aim your hands and fire a force, and it would fire a force into all of the components of all of the things kind of in that blast radius. So you could like knock down doors and stuff with that. And that was kind of something that never made it the final thing. And then looking back into the final one, this came out was a custom shader that I had made to make like the matrix death effect on some of the entities when they died. And how this works is basically just like breaking the world's position down into little segments and saying if it's within, like, if the particle is within this part of the world position, right now it's going to be a 1. If it's in this part, it's going to be a 0. And so like as the particles rise, they like transition from being a 1 and a 0. And I'm just making those 1s and 0s with like a line and a torus SDF. And I'm just discarding the pixels that are outside of a certain threshold of that SDF. So that's how that shader works. And then you can see how the open door script kind of changed as we went to the final one, where we just setting the positions because our animations got all buggy. So now we just set the door up. And yeah, so those are some of the scripts I worked on.